Our second speaker is Professor John Strauss. He's a professor of economics at University of Southern California. He was also an editor-in-chief of economic development and cultural change from 2003 to 2013. And he's also the principal investigator of Indonesian Family Life Survey and China Health and Retirement Survey, which are two surveys I know that a lot of people in this room are using. Let's welcome Professor Strauss.
Thank you. Here, I may need some help with this. Where's the... Okay. And where's this one? This one. Okay. How do I get the... How do I get the full screen? Sorry. Thank you. Thank you. Okay, thank you very much. This is joint work with Firman Witelar, Bondan Sukoki, colleagues of mine at Survey Meter in Indonesia. I'll let you read briefly this acknowledgement. This is a paper about a new, new to IFLS, measure of cognition that we borrowed from the health retirement study in the U.S., and it just goes to show the usefulness sometimes of large meetings. This came out of a conversation, long conversation that I had with Bob Willis and Rebecca Wong and Jack McCardle at a National Institute on Aging harmonization meeting where PIs of all the different aging studies in the world got together. This was a few years ago, and that basically resulted in what we ended up doing for Indonesia, also for China, and it's going to be used in a number of other countries as well. So, we're going to use some different measures of cognition in Indonesia, and in particular, a couple of new measures that again to IFLS that were borrowed but redone from the HRS in the US. And a lot of what I'm going to talk about is what are in these measures, because they're new and there's some issues that have been raised, whether they were really doable, useful in a developing country context. The answer is they are. And then start to show some initial correlations with underlying socioeconomic status and how, in particular, gender differences are affected by that. So, what happened? Thank you. So, as a number of you may know, in the cognitive psychology literature, there are different kinds of cognition that they define. Crystallized intelligence, which has to do with learning in school and things like that. Also fluid intelligence, which is what I'm more concerned about in this paper, which has to do more with abstract reasoning ability. And, well, you can read, there's some evidence in the psychology literature that fluid intelligence tends to peak during adolescence, whereas crystallized intelligence in mid-age, around 50 or so. And there's some good studies in the cognitive psychology literature showing this. There are different dimensions to fluid intelligence. Quantitative reasoning is one. So what we do here is we introduce a modification of an adaptive number series test. I'm going to show you exactly what that means, what that is in just a minute. Jim Smith, who's worked a lot in this literature, together with Jack McCardle and Bob Willis, have a very nice paper in Economic Journal in which they showed that number series is highly correlated with financial wealth in the HRS data, and in fact is the most highly correlated of the cognition measures in HRS with financial wealth. We're also going to look at a second, in this paper, at a second measure of fluid intelligence, one which is very widely used, the Raven's progressive matrix test, or a subset of it, and then measures of immediate and delayed word recall to measure episodic memory and questions from the so-called telephone interview of cognition status, tics to measure mental intactness. Exactly what I mean by all this we will get to. Just to point out that with the exception of number series, the mental intactness and word recall have been used by Jim Smith and Chinese colleagues in a couple of published papers showing that there are very large gender differences, women having much lower cognition scores, but the gender differences are particularly pronounced in China at older age groups where the education differences between gender is quite large, and they're much, much smaller among mid-age groups. Anyway, we'll get more to that. So the data are from the Indonesia Family Life Survey, the fifth wave. So IFLS is one of the oldest, I won't say it's the oldest, it's not, but one of the oldest panel household surveys in the developing world, one of the surveys that Andrew was saying we have all these sampling weight problems, which I'm sure we do, but I will claim we do better than almost anybody else. Andrew and I can talk later. So Wave 5 was conducted in 2014-15. It's all public. So it covers 21 years, starting in 1993. We're going to use a sample of 31,500 age 15 and above, separated into these three groups. A lot of what I'm going to talk about and the regressions are going to be 60 plus. Smaller sample, but anyway. First I'm going to show you a lot of detail about what the questions are and what the data look like. Most of the talk will actually be about that. When we get to regressions, we'll have these simple specifications. And again, none of this is causal or trying to be causal, just trying to show what are some basic correlations here. And these are the different cognitive measures that we're using in this paper. In 2003, we added the Raven's test, or a small subset of it, to some respondents, basically respondents aged 15 to 24, but not the entire sample. And that was in Wave 3 in 2000. In Wave 5, we basically started giving this to everybody over 15. So that's new. The adaptive number series test is new to Wave 5. Word recall mental intactness we added in Wave 4, and we kept in Wave 5. Basically, one of the things that I've been doing as PI of IFLS over the last, particularly since 2007, has been to try and harmonize IFLS to a fairly large degree with the other major aging surveys around the world. HRS, ELSA in England, now Charles in China, Lassie in India, and so forth. So let me talk about the number series test. So again, this was adapted, changed and adapted from what HRS had done. It's a series of 6 blocks taken from 15 questions, actually 16 in the case of IFLS, that could be asked. People get 3 questions. Everybody gets the same 3 questions to begin with. And depending on how many of those 3 questions they answer correctly, they get a second set of 3 questions of greater or less difficulty more difficulty if they answered more of the original 3 questions correctly. So it's adaptive in that sense. And this is one reason we can do this very easily in the field is that we no longer use paper and pencil. We use CAPI, computer-assisted personal interviews. We started doing that in IFLS 5. It was a huge advantage, very big advantage, and this is the kind of thing that you can do very easily in CAPI that in paper and pencil, much more difficult to do. So here's some examples. Here are the questions. Okay? So the first 3 questions, 7, 8, a blank, which they have to fill in, and then 10. So obviously the blank here is 9. Okay? The respondents get no, they get no help. It's unlike, say, Ravens, where Ravens you show them a series of 6 possible answers. They have to choose one of them. So that's not the case. It's just open-ended. Okay. So these are the first block of 3. This is the block that if you got all 3 wrong, you would go into. You go into this block if you got 1 right. You go into this block if you got 2 right, and you go into that block if you get 3 right. Okay. The main difference of this between what was in HRS was that we were worried, we being McCardle and Willis and Rebecca Wong and myself, we were worried that in a low income, low education, low numeracy environment, such as in a low income country like Indonesia or parts of China, that the difficulty of the HRS questions may be too much. That you might get a substantial fraction of people who couldn't answer anything, and that therefore it would not be very discriminating. So McCardle, he's retired now, but so that's why is a very well-known cognition psychologist. He worked with Richard Woodcock. So these questions are all from the Woodcock-Johnson battery of questions. Dick Woodcock is a very, very famous psychologist, cognitive psychologist. So McCardle and Woodcock worked together to take from Woodcock-Johnson battery of question a subset that were easier than HRS uses, plus a subset that HRS uses. And I'll show you in just a minute the differences in the scores. Now, we weren't sure how this was going to work, so we did extensive pre-tests in both Indonesia and in Mexico. Mexico through MHAS, Mexican Health Aging Survey, that Rebecca Wong heads now, and Indonesia through IFLS. So we did extensive pre-testing. McCardle and a colleague of his analyzed the data and basically showed that they worked pretty well. And you can see that here. This is all ages, 15. So this is the percent that get every one of these questions correct. And the important point here is there's a lot of variation. And we can see that better here in this table. So again, this is age 15 plus. I'm going to show you the elderly in just a minute. So only 3.1% got nothing right in the entire sample. Okay? And as you can see, only 1.3% got everything right. So there's substantial variation. So that's very good. That was really important to demonstrate in the pre-tests because there were a lot of disbelievers. There were a number of people in the aging research community who thought that this would not work in very low income, low numeracy environments. We showed them no, it can work very well. Okay? These W scores are the scores, are numeric scores that are given. They're done from a model, an item Sorry. I guess for the filming, that may be a problem. I think everybody can hear me, though, in the room. So the W scores are psychometric scores that are given. There's HRS has a document that gives a little bit of detail, but unfortunately in this literature, one of the problems is that there is a lot of ownership. And so these things are not necessarily for free. Psychologists love to invent new tests, and then they get copyright over them. It's actually quite a big problem in that literature. We were able to get around that because Woodcock is the main person, and he was cooperating with us, and he was interested. Interestingly, so these W scores, the differences, say, of 10 units, the difference between 299 and 309 is supposed to represent the same difference as the difference between, say, 500 and 510. Okay? That's how one of the properties of these W scores. The lowest W score in HRS was basically 400. And the lowest W score in this revised one, you can see 299. So we do go lower. We don't go much higher, a little bit less high, but we do go substantially lower than HRS. Let me show you this. So this shows the distribution for all the ages, well, 15 to 34, 35 to 59, 60 and above by level of education. Let's focus over here, elderly. And what we can see, only 20% of 60 and above got nothing right, could answer nothing. So I guess it depends, you know, whether you think the glass is half full, half empty. I think it's 3/4 full, maybe only 1/4 empty. I think it's pretty good. There's a lot of variation. Even if you take a subset of the elderly, those with absolutely no schooling at all, which in Indonesia there's an important subset like that, maybe 40% could get nothing. This is the distribution. But you still get a fair amount of variation. And we could discuss a lot of reasons. One reason is that in rural areas in low-income countries, most of these people are farmers, or if they're not farmers, run family businesses, and they know how to count. They know about prices, and they know about profits, and they can count. So numeracy is not nearly as low as what a lot of people sitting in Bethesda, Maryland, or other universities in the US or Europe might think. So that's very good. There's spread in the data. And I can also say, so the data are public. We use this exact same test in Charles in wave 3, and wave 3 just became public last week. So those of you interested in looking at China, you can get these data now from China, and at a later point, not too late, we're actually going to combine some China data, US, England, and data, doing some international comparisons. Because one of the beauties of the W score, the way it's constructed, is it's, at least in principle, comparable across countries, across groups, and so on. Okay, so Ravens, we did an abridged version of the Ravens test, and we do word recall, immediate and direct word recall. The deal there is respondents are read 10 nouns slowly, and then they're asked to remember how many of the 10. And they're asked to remember it immediately. Then we start asking them other questions, and about 4 minutes later, they're asked to remember delayed. Okay? And so that's also a measure. This shows the distribution of the Ravens for older, and again with no schooling, they're up to 8 questions. And again, you can see pretty good spread, even for people. Now, Raven's test, for those of you who don't know, it's a series of pictures. And then there's one blank, and you're given a series of 6 pictures to fill in the blank. And there's no letters, there's no numbers. It's basically patterns. Okay? I don't have an example here. I should. But, so there's spread in the data there. Word recall, the same thing. Good spread in the data, even amongst elderly with no schooling. So mental intactness is from the telephone interview of cognition status. So there are 3 questions having to do with date orientation. People are asked to serially subtract 7 from 100 up to 5 times. And then drawing 2 overlapping pentagons. Basically, they look at a picture and then they recreate the picture themselves. Mental intactness, we only do these questions for the elderly. And this is what the, out of 9 different possible questions, this is what the distribution looks like. And again, even those no schooling, good spread. Okay, so normally I would stop and ask for questions, but I guess we'll do that at the end. So let's get into some findings. So the first thing I'll talk about, this is a simple correlation matrix. So what I didn't tell you, but should have, Raven's is also a measure of fluid intelligence, of fluid cognition, as is the number series. But you can see they're not perfectly correlated. There's correlation, but it's for sure not the same thing. And word recall, mental intactness, so you can see between 0.4 and 0.5 are the raw correlations in the IFLS data. So let me just talk about some simple multivariate analysis, very simple regressions. So this is from the first specification in which we regress either the W score, Raven score, word recall, mental intactness score, and we regress it on a female dummy. We do it for these 3 age groups. Within each of the age groups, we have 5-year age dummies, okay? And then a female dummy, and then we have dummies or fixed effects for district and a dummy for rural or urban within the district. So, a couple of points from here. Everything, very, very significant gender differences. They're all negative. Women do worse on all these things. But notice the age pattern, which is pretty universal. It's elderly women who do much worse than younger women, although younger women do worse as well. But elderly women do much, much worse, and that's true across the board. Interestingly, for the word recall, the youngest women actually do better, not worse. Actually, this is something, you may know this, Jim. Yahweh says she's found this in the Charles data. Because this is not what we're used to seeing in most of this literature. Okay, so that's the first point. So now I'm going to focus only on the elderly regressions. And in the second specification, we add variables for dummy variables for completed schooling level and linear spline in the log of household assets. Okay. In the third specification, we add several community variables, which I'll talk about in just a second. And the fourth specification, we have community, basically local community fixed effects. Now, unfortunately, specification 1's not here. It would have been useful. Couldn't fit it in. Let's focus on the W score. So the coefficient on the gender dummies, minus 36 in the first specification without all these other controls, falls to minus 11.3 oops, sorry, and pretty much stays there in the other specifications. It's still significant, but it's 1/3 the level of what it was without adding education and splines. Adding the community variables does nothing more. Now, the Ravens test, it's different, a little, because Ravens, which was minus 0.5 in the first specification, basically goes to 0 and stays at 0. Okay. Word recall, oops, which was positive, sorry, it was negative, minus 0.285, goes to positive and significant once you add education and assets, and stays there. Adding community variables does nothing. And mental intactness, which was minus 0.846, basically goes to 0, very small positive numbers, but not statistically significant at any standard level. So basically, for word recall, mental intactness, and the Ravens score, the gender effects go away completely once you control for education and household assets. Adding community variables doesn't do anything more. But for the number series, it doesn't go away completely, but it is reduced by 2/3. So for the community influence, what we do, and this is borrowing from, in part from, heavily actually, from work that Jim Smith has done with Xiaoyan Lei and Yahui Zhao in China, is we take community average education, basically the percent of people in the community who have these different levels of education, and it splines in average assets, household assets at the community level. You do get individual significance of some of these things, but as I showed you earlier, they have no impact at all on the gender coefficients. So I can conclude. So we focus on this gender differential, finding a significant negative differential for women. It's substantially less for the younger age group, for whom schooling differentials are smaller, declines substantially or disappears entirely once we control for SES. Adding community measures related to mean schooling and asset levels does not affect the gender differential. And then finally, stress that the data are cross-sectional. We can't say anything about yet about dynamics of cognition and its SES gradient. Future waves of IFLS will be able to do that. But the most important message that I want to send is the usefulness of these cognition measures, and in particular this new number series, and how useful it is even in low numeracy, low literacy environments such as Indonesia and such as China. So, thank you. Yeah. Yeah, I can hear you fine. No, well, others may not, Jim. I can hear you.
John, 42-14-71-6. What's the next number? Just kidding.
I'm elderly now.
Striking the difference that I see from what we found in China is in China, the community measures of community resources did matter on the male-female differences. And in particular, low resource communities use their resources to the favor of boys and the disfavor of girls. Is your you know more about Indonesia than I do. Is your intuition about Indonesia that it's fundamentally different in this regard than China?
Yeah. There are important gender gender differences in, for example, schooling among the elderly in Indonesia. So that, and not among the younger group. So that mimics China. But Indonesia, female schooling was going up much more rapidly in earlier times than in China. That's part of what I was saying.
Other questions?
Just one more thing, if I can say quickly, is that it's really important when you're using data, survey data particularly, to understand exactly how the data are collected and exactly what they mean, especially when they're fairly new concept data like this adoptive number series. A lot of people don't do that, but I think it's really important. And again, the good news from here is that at least in Indonesia, and it's also true in China where we have begun to look at the same thing, apparently very useful, this adoptive number series as a measure of food intelligence, a measure of food cognition.